It is 6:54 a.m. in Starbase, Texas, a gorgeous sunrise, and Starship is targeting liftoff in just 30 minutes and 18 seconds from now at 7:25 a.m. Central Time. As you can see, it is a beautiful day in South Texas for the 5th flight test of Starship. Good morning, Star people. I'm Kate Tice.
And I'm Jesse Anderson, and we are joining you live from SpaceX Hawthorne with a big crowd here this morning. It's been roughly 4 months since our last Starship flight, and we've got a big morning ahead of us.
Flight 5 has a few primary objectives and one big first. We may be attempting to catch the Super Heavy booster. The teams at Starbase have been hard at work around the clock upgrading hardware across the entire tower with focus on the chopsticks, the 2 mechanical arms that will reach out and catch the returning booster. We're only going to attempt the catch if everything on the booster and tower checks out after launch, but either way, excitement is definitely guaranteed.
Definitely. Today's Starship features a completely reworked heat shield with stronger tiles and a secondary layer, which is an extra layer of protection for the ship that will protect from any of the that will help protect if there's any missing or damaged tiles. Now, not only did we replace the entire heat shield with our newest generation of stronger tiles for today's flight, we'll also be flying a handful of aluminum tiles that are there to help the team understand the thermodynamic environment during re-entry. If you were with us for Flight 4, you'll know how hard those heat shield tiles worked during the ship's re-entry.
Did they ever? As you can see there, they worked incredibly hard. This big heat shield rework that we're talking about promises to increase the likelihood of Starship being better protected during controlled re-entry as it heads towards its flip maneuver and landing burn for a soft splashdown on target in the Indian Ocean, just like we did in Flight 4. And we'll have to wait and see, keep your fingers crossed, but we may have some new views in store for you today as well.
Right, like all test flights, we want to learn as much as possible, and views of Starship during all phases of flight help us to keep improving the vehicle for recovery and reuse.
Now, thinking forward to when Starship is flying regularly, it will take the heaviest payloads to space, land humans on the moon again after more than half a century, and ultimately fly people further into space than ever before. And getting there will require us to rapidly iterate and fly often, which is why we're working so hard to scale operations at Starbase.
Yeah, the faster that we learn now, the faster we can improve and evolve Starship to achieve reliable flights and rapid reusability. We've been designing this vehicle from day one to realize a vision of having an entire city of people on Mars, something we know will take launching millions of pounds of cargo and equipment into space spread across thousands of flights. This future will require many Starships that can fly again and again, and today's flight is a critical step on that path.
So buckle up your seatbelts because here we go. The moon and Mars are not nearly as far in the future as you may think. In fact, we're planning to send Starships to Mars as soon as 2026.
You might be familiar with the Starlink logo, and there you can see it on your screen. It's an iconic representation of the Mars transfer orbit, also called the home and transfer orbit. This is how fundamental Mars is to SpaceX. This transfer window, or a time when the Earth and Mars are the closest to each other, opens every 26 months and is only open for about 2 to 3 months at a time for a vehicle with Starship's power. And it just so happens that the next Mars transfer window opens in 2 years towards the end of 2026.
Yeah, lining up a launch to Mars is similar to how we launched to the International Space Station, where we time launches to match the station's orbit. If we didn't do this, we'd need more propellant and more time to get there.
Exactly. So the first opportunity that we have to fly Starships to Mars, we plan on doing it. These first flights to Mars will be uncrewed and will test the reliability of landing intact. If those landings go well, the first crewed flights will follow soon after.
So it's safe to say it's all happening, and flights like today's are what's going to get us there. Not only have we made several improvements to the Starship flying today based on what we've learned from our last flight, including extensive upgrades to Starship's hardware and software, we've also made improvements to the launch tower and catch mechanisms.
And if you've noticed in some of the live views this morning, our teams have completed stacking the second launch tower, which will be coming online next year. Having 2 operational launch towers paired with ships and boosters rolling off the line in our new Star Factory will allow us to increase our flight cadence and test even more rapidly. And just a few miles away from the 2 towers, things are moving really fast at the heart of Starbase. Star Factory is rapidly coming online, with production teams already using the space as construction continues. The 1 million square foot Star Factory brings many parts of the manufacturing process under one roof for the first time, enabling moving as much system integration work as possible earlier in the build process, with the goal of eventually producing hundreds of Starships a year.
That's crazy. It's such an impressive building. So, for example, teams can assemble an entire nose cone structure of a ship into a single piece and work on its internal systems all in one place. So if you're working on Starship and you have a question about the steps that you're working that happen before or after yours, instead of having to leave the building and go and find the person or the team with the answer, or waste time sending an email and waiting for their response, odds are you're right next to that person or team, and now you're working right alongside them, so you don't have to wait for a response.
Yeah, exactly. It makes it a lot more efficient and faster to communicate. So not only are we rapidly iterating on these spacecraft themselves, but we're also innovating the way that they're made.
It's almost too much to keep up with.
We're also posting updates on our account on X if you can't keep up. That'll help you. So if you don't already, make sure that you follow us at SpaceX on X. And I have a feeling it's going to get pretty busy.
Oh, that is definitely an understatement.
And it's definitely going to be very exciting today. So with that, let's meet today's Starship on the pad. Starship features 2 major parts: the ship, which has 6 Raptor engines, and the Super Heavy booster, which has 33 Raptor engines. The current iteration of Starship is essentially an experimental vehicle flying for development. With a few planned upgrades, Starship will have 3 times the thrust of Saturn V, plus the added benefit of full reusability. Starship 2 will be capable of carrying more than 100 tons to orbit, and Starship 3 will be able to lift more than 200 tons to orbit. The amount of mass we're able to launch per rocket is crucial to creating a self-sustaining city on Mars.
Now, to get a sense of how big Starship is, let's start with the average size human, which is about 2 meters high. Towering over our average human is the length of the Millennium Falcon, which comes in at 35 meters. Our Falcon 9 rocket, with the payload fairing attached, is double the size of the Millennium Falcon, standing at 70 meters. And nearly twice the size of that is the fully integrated Starship at 121 meters tall. The ship itself is about 50 meters tall, and the Super Heavy booster alone stands about 71 meters. And even crazier, eventually the ship and booster will get even taller with future design iterations.
Can't imagine it being taller than that. Starship's first stage has a diameter of roughly 2.5 times that of Falcon 9, and with 33 much larger Raptor engines, which you can see there on your screen. Moving up the vehicle, the ship features 6 Raptors, 3 sea-level engines, and 3 vacuum engines, which are optimized to operate in the vacuum of space. The ship is designed for vertical takeoff and landing on any hard surface, like the surface of the moon. The ship is also outfitted with 4 flaps to help aerodynamically control the vehicle's attitude during atmospheric flight and enable a precision landing.
To reach full reusability, ship must survive entry not just once, but over and over again. It took the teams at SpaceX about 3 years to develop the heat shield on Starship, and development for improvements is still ongoing. The ship's heat shield is composed of 18,000 hexagonal ceramic tiles designed to insulate the vehicle during atmospheric entry, where temperatures can be as high as 2,600 degrees Fahrenheit. And naturally, the tiles are designed for rapid reuse with no refurbishment between flights. As we mentioned earlier, today's Starship features a completely reworked heat shield with stronger tiles and a secondary protective layer. This promises to increase our chances of Starship making it through a controlled re-entry, and hopefully a little more intact this time around. And in between our first and second stages is our hot stage, which we last saw in action on flights 2, 3, and 4. Speaking of, let's take a trip back in time and talk about that last flight. On June 6th, Starship successfully lifted off at 7:50 a.m. Central Time from Starbase, Texas, cleared the launch tower, and went on to accomplish several major milestones and firsts. As you can see there, Super Heavy booster lifted off successfully and completed a full duration ascent burn. I love the view of the sound waves there. Following separation, Super Heavy booster successfully completed its flip maneuver, boost back burn as well to send it toward the splashdown zone, and it also jettisoned the hot stage adapter, as you can see there. We don't have to jettison that adapter in future iterations because it'll be a different design. Now, as you can see here, the booster is returning back to Earth using those hypersonic grid fins to steer it towards a precise landing in the Gulf of Mexico. The footage that we have coming up here, there it is from the buoy. I still remember seeing this on X for the first time, and it was so incredible to see that booster coming down, ending its flight with a soft splashdown 7 minutes and 24 seconds into the flight, and the crowd went wild.
And so did we. Starship's 6 second-stage Raptor engine successfully powered the vehicle to space and placed it on a trajectory that would re-enter less than 1 orbit later over the Indian Ocean. And following a coast phase in space, Starship re-entered the Earth's atmosphere, successfully making it through the phases of peak heating and max aerodynamic pressure, and demonstrating the ability to control the vehicle using its flaps while descending through the atmosphere at hypersonic speeds. And of course, Starlink on Starship once again enabled real-time telemetry and live high-definition video throughout every phase of entry, with external cameras providing views all the way to the flight's conclusion.
Flight 4 ended with Starship, with, again, the crowd going bonkers, with Starship igniting its 3 center Raptor engines and executing the first flip maneuver and landing burn that we had seen since our high-altitude campaign. And that was followed by a soft splashdown of the ship in the Indian Ocean 1 hour and 6 minutes later.
And we were all glued to the monitors watching the little flap that could the whole way down. Seeing the landing burn and splashdown was an incredible moment for the entire SpaceX team, and we'll be looking out for many more of these incredible moments today.
All right, so while today's mission profile is similar to Flight 4, we got a couple new test objectives, including catching the booster back at the launch tower.
In about 18 minutes from now, Super Heavy will ignite its 33 Raptor engines and lift off from Starbase. A little more than 2.5 minutes into flight, the Super Heavy booster will separate from the ship in a hot stage separation. After that separation, the booster will perform a flip maneuver followed by a boost back burn. And about 2 seconds after that burn ends, we'll jettison the booster's hot stage. As it heads back towards the ground, the booster will either attempt a landing, will have a landing burn, but then will either return to the tower or splashing down in the Gulf of Mexico.
Meanwhile, the ship's engines will remain lit for just under 6 minutes during its ascent phase before shutting down for the coast. The ship will coast for about 40 minutes or so, reaching a peak altitude of about 213 kilometers. After that coast phase, the ship will be attempting a controlled re-entry, including a flip maneuver and landing burn, like we saw on Flight 4, just before splashing down in the Indian Ocean. Now, we say attempting because, again, this is just a test and nothing is guaranteed.
Except excitement.
Well, of course there is that. Now, both the booster and ship have to contend with some extreme conditions on re-entry, which is where those heat shield tiles will be put to the test.
For this flight test, we do not expect to recover any hardware from the ship. With the exception of Falcon, this is no different than what happens to most rockets flying today that are expended, meaning that they fall into the ocean after completing their mission. Eventually, we will return and reuse Super Heavy boosters and Starships as we do today with Falcon 9 and Falcon Heavy boosters. And in fact, we've landed Falcon boosters 352 times to date.
Oh, man, I hear you say that number, and that is just wild. I still remember the night, or at least most of the night, that that Falcon landed for the first time, and it still feels like yesterday.
Yeah, definitely one of my favorite moments at SpaceX. And returning Super Heavy promises to be an even more impressive sight and a huge moment on the road to rapid reusability.
Yeah, speaking of rapid reusability, future Starship designs will give Super Heavy boosters a lighter weight and integrated hot stage intended for full reusability, which will mitigate the need to jettison the hot stage like we'll do today. Similarly, even though ship recovery is not expected, the telemetry and data we receive all the way to the end is what we're what we're looking for, and is what will get us to a rapidly reusable Starship of the future.
Yeah, exactly. In other words, just like previous Starship flights, the payload for this mission is the data. All right. Now that we have a handle on today's flight test, let's check in with Dan, who is right in the middle of the action. He's just a few kilometers from Starship on the pad. How's it going, Dan?
It's going great, Jesse. Welcome back to Starbase, everybody. It's been far too long. Little change of scenery this time. Right behind me is the Launch Control Center, where our flight controllers are counting down to our liftoff at 7:25 a.m. Central. We are a little bit later in our window. The main reason is we're working to clear out the range. Have not been tracking any technical issues so far to preclude that launch. So 7:25 a.m. Central, 12:25 UTC is where we're marching down to. As you can see, we're actively loading propellants onboard Super Heavy and Starship. Liquid methane for your fuel, liquid oxygen for the oxidizer. Prop load on the ship started at about T-minus 49 minutes, booster at T-minus 40 minutes. We're going to keep loading propellants on those vehicles right down to the wire. Ship will close out at about 3 minutes and 20 seconds before T0, and then booster just about 30 seconds later. Now, with our startup sequence, it's going to look very similar to what you saw on Flight 4. We already tested it with this booster and its static fire. We're going to see the Raptors start to make fire at about T-minus 3 seconds, and then we'll start them up in 3 different banks. The first inner 13 will fire, and then about a second later, 15 of the outer ring engines, and then about 0.8 of a second after that, those final 5. Another reminder, if we need to hold, we have a built-in spot at T-minus 40 seconds. We can hold for stuff like if we need to finish clearing the range or if any other technical issues pop up, just kind of in the last second. But if there's nothing holding us back, we're going to go right past that and go down to 0. So, I mean, as of right now, we're just under 14 minutes away from liftoff, not working any technical issues. Range is expected to clear. We're just clearing out a few more boats. And as you can see, the weather is perfect. We had 100% go for launch from the weather officer, so that was pretty unprecedented and something we really like to hear. If we're not able to go today, since we are loading prop, it would likely be about 48 hours before our next attempt. But good thing we're going to launch today. Really looking forward to being able to turn around and see it this time, counting down to 7:25 a.m. Central. And I'll see you guys in a couple minutes. I'll send it back to you in Hawthorne.
Thanks, Dan. Now, one of the most exciting objectives for Flight 5 today is attempting to return the booster to the launch site that you see right there, and it will be caught by the tower. We refer to this simply as booster catch.
As you've heard us say, Starship and Super Heavy are designed to be rapidly reused, which is why we've developed a novel way of returning the vehicles that leverages the same hardware we use for stacking ahead of flight.
Right now, when we recover our Falcon boosters, they either return to a separate landing zone on land or to a drone ship in the ocean, both of which require time to transport the vehicle back to the launch site. In order for us to achieve truly rapid reusability, we need a quicker turnaround. And you can't get much faster than returning the launch vehicle right back to the launch site where it needs to be in order to launch again.
For today's booster catch attempt, while there are thousands of criteria that need to be met, there are 3 primary gates that will be in play. In order to proceed, automated checks have to indicate we have a healthy booster and a healthy tower, and the flight director must issue a manual command, which is informed by manual checks from the flight control team. If this command is not sent prior to the completion of the boost back burn, or if automated health checks show unacceptable conditions with Super Heavy or the tower, the booster will default to a trajectory that takes it to a landing burn and soft splashdown in the Gulf of Mexico.
Now, thinking to the future when we're operational, after a booster returns to the launch tower, it will be inspected and reloaded with propellants and then ready to launch another ship to orbit. For today's test, however, we're only going to attempt the catch, like Jesse said, if everything on the booster and tower checks out after launch. And of course, we will let you know as soon as we know if it's a go. We're going to be listening very keenly for that call out. Now, as always, we accept no compromises when it comes to the safety of the public and our team. So to that end, the area all around the pad and the flight path are cleared well in advance.
Exactly. A lot of things have to go right in order to line up the booster catch. So don't be surprised if we don't attempt the catch today. Either way, today's flight will generate data that will continue to inform our future flights and help us get to that operational cadence.
Yeah. Oh, you can't forget what else it will generate.
Are you thinking what I'm thinking?
I mean, I was going to say a sonic boom.
Oh, I was going to say excitement, but that's a really good reminder.
Now, if we do make it to a catch attempt today, Super Heavy may generate a sonic boom upon its return. And that's basically a brief thunder-like noise that we hear when an aircraft or other object travels faster than the speed of sound. Anyone that has been in the area for a Falcon 9 land landing in Florida or California, or even some space shuttle landings, may have heard one of these.
Generally, the only impact in those surrounding areas of a sonic boom is the brief noise, with variables like weather and distance impacting if or how the sonic boom is heard. Here's a brief look at how these sonic booms look and sound on Falcon.
I know a lot of people will be excited when they hear the sonic boom.
And these are going to provide quite a show, because you're going to hear those sonic booms.
Sonic boom is great for us.
That thunderclap broke the sound barrier.
Side booster separation confirmed.
Just heard the 2 sonic booms here in the room.
Booster landing confirmed.
As our test flights continue, we plan to demonstrate ship-to-ship propellant transfer, which will be important in preparation for Starship taking astronauts to the moon as part of NASA's Artemis program. SpaceX will perform one uncrewed demonstration flight before NASA's Artemis 3 mission, which will be the first human surface expedition since 1972. Also, in preparation for missions to the moon and Mars, we're gaining tons of knowledge from our human spaceflight missions, including free flyer flights like our recent commercial astronaut mission, Polaris Dawn.
Polaris Dawn was the first of up to 3 missions in the Polaris program, which is demonstrating new technologies, conducting extensive research, and will culminate in a flight of Starship with humans on board.
After nearly 5 days in orbit, Dragon and the 4-person Polaris Dawn crew safely splashed down on September 15th off the coast of Florida, completing the first human spaceflight mission of the Polaris program. The Polaris Dawn crew performed some incredible firsts during their mission. Dragon and the crew reached 1,408.1 kilometers, the highest Earth orbit ever flown, and the farthest humans have been from our planet since the Apollo program.
The crew also performed the first ever commercial EVA, or extravehicular activity. And as you can see there, they were wearing the new EVA suits that we developed here in-house. This was an incredible moment to see Jared and then later Sarah emerge and perform this EVA with Earth behind. Now, in addition to this incredible spacewalk, they also conducted about 36 research studies and experiments from 31 partner institutions, including NASA. And in addition to all of that, they also tested Starlink laser-based communications in space. The data gathered from Polaris Dawn missions is invaluable, much like the data that we're going to see after today's flight test of Starship. So we're coming down to T-minus about 7 minutes. Let's check in with Dan.
Hey, thanks, Kate. So yeah, we're right at about 7 minutes away from launch. The main thing we are still working is that range clear. Again, we have to make sure boats, airspace, everything is cleared out of the way for our ascent corridor, basically the Gulf of Mexico, where we're launching through before we can actually launch. And so we're working on clearing out just a few more boats. We do have a window, remember. So if we end up holding at like a T-minus 40 seconds, we can hold for several minutes, allow those boats to get out of the way, and then we can launch. Our window is from 7 to 7:30 Central, so we don't have a huge amount of time today, but we do have some margin if we need to work with it to still get off the ground today. For now, though, we're coming up on finishing prop load on both vehicles. Header tanks are pretty much topped out on the ship. Those are going to be used for its landing burn. And again, we're going to be closing out all of the prop load at about T-minus 3 minutes, 20 seconds for the ship, and then just 30 seconds later for booster. One kind of cool thing to talk about, so the folks in launch control behind me after liftoff, they're going to have some pretty special tasks today if we're going to go through with the catch. They're going to be doing some really detailed inspections just visually of all of the different tower systems, a lot of those things that we upgraded, just to make sure that we are in the right posture to actually proceed with the catch. So they'll be working kind of fast and furious behind the scenes to inform the flight director's manual command to send the booster back. So if we hear that command being sent, that's going to be just the roof's going to come off. That's going to be a really exciting moment. So otherwise, if we don't go today, as you guys talked about, there is a chance, and if we don't send the booster back, we'll do a landing burn and a splashdown in the Gulf, and then that's just another landing burn to gather more data, learn more lessons from, and then we'll come back and try the catch again on the next one. But as of right now, we're coming up on 5 minutes. There is a chance that we'll hold or extend into the end of our window, so don't be surprised if that ends up happening. But if those boats do get out of the way, we are just about 5 minutes away from launch. So I'll check back in just a moment, but back over to you, Kate and Jesse.
Thanks, Dan. Our rapid iterative development approach has been the basis for all of SpaceX's major innovative advancements, including Falcon, Dragon, and Starlink. Today, we're testing hardware and systems, and we need to know how they perform under the most extreme conditions. We'd much rather find the bugs now during testing than later on when there's more on the line. And to reiterate, while we do determine an acceptable level of technical risk on our vehicle and pad in order to learn as fast as possible, we accept no compromises when it comes to the safety of the public or our team. So that is to say, this is only the fifth of many future flight tests of Starship before it becomes fully operational.
You might remember the Starlink panels that are incorporated into Starship, and you can see them there on your screen, those rectangular panels on Starship's nose cone. Starlink brings us the epic views in space and on re-entry, and also helps deliver us the critical flight data engineers need to continue development. In addition to enabling our rapid iteration on Starship, Starlink is also enabling life-saving communication here on Earth. SpaceX is sending tens of thousands of Starlink kits in response to Hurricanes Helene and Milton, and providing free service through the end of the year to support recovery efforts. The Starlink team also worked with T-Mobile to activate our direct-to-cell satellites to provide basic texting on T-Mobile and emergency alerts for all phones and carriers of those in affected areas. If a phone connects to a Starlink satellite, it will have 1 to 2 bars of signal and show T-Mobile SpaceX in the network name. SpaceX's direct-to-cell constellation has not been fully deployed, so these services are being delivered on a best effort basis.
Starlink is enabling life-saving communication here on Earth and continues to help us push the limits in space. In the short term, by providing great views and real-time data on our next few flights, particularly through re-entry, which historically is a blackout period for all communications.
All right, so we're coming up on 2 minutes, 30 seconds away from launch. We were hearing like there was a pretty good chance we were going to hold at T-minus 40 seconds, but surprise, now it sounds like we might not be. So we are just a little over 2 minutes away, so a couple more things going to be happening. We did just close out our propellant load on the ship and the booster, so 10 million pounds of propellant on that vehicle on the pad here at Starbase, getting ready to go. We're going to start clearing out all of the lines that are basically pushing all of that propellant to the vehicles. Those get cleaned out or cleared out on the ground before we lift off. We're doing some final checks on the vehicle, the thrust vector control that we're going to use to steer it, as well as the guidance system doing its final alignment, just a lot of our final checkouts. But we are starting to hear that it looks like the range is going to be clear at our liftoff time of 7:25 a.m. Central, 12:25 UTC. So that puts us 1 minute, 20 seconds away from launch. Still not tracking any technical issues. That range clear is the only thing that's been potentially poking at our launch. So I'm going to start to quiet down. We'll hear our flight director for today, Tristan Pierce, give some of the final call outs. As of right now, we are 1 minute away from liftoff.
Flight directors go for launch.
Best words you could possibly hear 20 seconds away from liftoff.
T-minus 5, 4, 3, 2, 1. We have liftoff.
Vehicles pitching downrange. Booster after chamber pressure nominal.
"30 seconds into the flight, the rumble's just starting to reach us here at launch control.
Booster and ship,
That
avionics
is
power,
the
telemetry
sound
nominal.
of 33 Raptor engines.
Max Q.
Now pass through the maximum aerodynamic pressure, the most stress the vehicle's going to see on the way uphill. All right, our next major milestone coming up, it's going to be hot staging. We're going to see the engines ignite on ship to push it away from the booster. All right, so hot staging is going to be the next thing coming up. First, we're going to see the booster's engines start to shut down, all but 3. We're going to do what's called most engines cut off instead of main engine cut off, because 3 are going to keep going, and then we're going to see the engines on ship ignite. Right now, the tower team is doing their go, no go. And we might hear some really good words soon, too. All right. Can still see it up behind me. That is one of the most gorgeous things I've ever seen in my entire life. Coming up on hot staging next.
Ship engine
There's
startup.
most engines cut off.
Stage separation. Booster
Stage
separation.
separation.
Startup.
Hot stage separation confirmed. Ship under its own power. I'm seeing 6 out of 6 Raptors lit. Hopefully I got a booster on the way back to me. I'm going to send it to you guys in Hawthorne.
Oh man, that was absolutely incredible. I loved how the crowd
Chamber pressure is nominal.
here in Hawthorne all went ooh at that first view of the blue flames from the booster. As you can see there, first stage currently performing, or excuse me, is now making its way back to the launch site. Again, we are
Ship avionics power and telemetry nominal.
the booster and the tower are both performing automated checks to make sure we are go for the booster to return to the launch pad for that catch. And once those are complete, the flight director.
Booster, boost back burn, shutdown.
Flight directors go for booster return.
And we did hear that the tower is go for catch. So that was one of the big criteria we were looking for.
this view
We'll
here.
wait to hear that the go for catch has been sent.
Beautiful view here from the ship.
And so exciting to hear that we got a go for booster catch. That means it's going to be a really exciting morning. Again, the booster is making its way back towards now land in order to make that catch attempt in the tower.
So incredible to see these views. You can see the ship on the right-hand side of your screen. All 6 Raptor engines are under full power. Once again, the booster is making its way back to the launch site. We are going to try and catch it using the chopsticks on the launch tower, the exact same tower that it just launched from just, 5 minutes ago.
Yeah, and the booster...
Starship on nominal
Guys,
trajectory.
I can confirm the command was sent for the booster to come back.
That is
So I'm
incredible
looking
news.
up right now. It's pretty much right overhead of us, and we can see it starting to come down.
I can't wait for us to hear the sonic boom through Dan's mic.
Right.
That is going to be incredible. It was so cool to hear the liftoff. And so once again, a successful on-time liftoff of Starship Flight 5. The ship has separated from the booster. The booster is there on your screen. It is making its way back to the launch site. We are going to attempt the catch using the chopsticks. We did hear the confirmation that the command was sent to the tower. We are go for catch.
And in order to...
And guys, we should just be about 30 seconds away from our landing burn. It's going to happen in 3 phases. We're going to land at 13 engines, burn off all of that velocity. Oh, we can see it coming down through the plume.
Booster coming in hot for booster catch.
We're going to ignite 13 of those Raptor engines, and this view is incredible right now. You can see how fast this vehicle is moving on the left-hand screen.
Landing burn has
13
been
engines.
ignited. We're now down to 3 Raptor engines. We can see those chopsticks now in the air.
Shutdown.
Megavilla has popped the booster.
This is absolutely insane. On the first ever attempt, we have successfully caught the Super Heavy booster back at the launch tower.
What an incredible view!
Are you kidding me?
Dan,
Wow.
I don't know about you, but we're losing our stuff up here.
Starship is terminal bed.
Guys, I'm sorry. Like, even in this day and age, what we just saw, that looked like magic. Oh, wow.
Dan,
Wow.
your view must have been insane! We are still going wild over here over this.
Folks, this is a day for the engineering history books. This is a live view of the Super Heavy booster as it has just been successfully caught back at the very same launch tower that it just came from. Dan, I love this. You are reflecting exactly what everybody else here in Hawthorne, except maybe a little bit more because you got to see it with your own eyes.
How was that?
Ship
We
engine
got
cut
it.
off.
Well, I mean, I can't even describe that. Oh, by the way, main engine cut off, ship's in orbit, but I am like shaking right now. That was...
Yeah, This is not,
Yeah,
I mean,
let's check in on ship.
it's hard to believe that.
Starship nominal orbit insertion.
All right, exciting news there. It's hard to believe that, booster isn't the only excitement that we have today. Just confirmation there, a gorgeous view of planet Earth behind the ship.
Saved.
And it is now in the orbit that we expected it to. This is just an incredible day. Live views there as the booster vents, some pressures there. That is a live view from the top of the tower looking at the chopsticks.
I am still in disbelief. I'm trying to catch my tears just like the chopsticks caught the booster. It has been nonstop since liftoff. And we are all so excited about everything that's been happening so far this morning. With the booster having completed its job for today, we are going to take a short break for the next 30 minutes. We'll return back at T plus 40 minutes while the ship continues to coast before re-entry.
Oh, man. And as with previous flights, Starlink may actually enable us to talk with the ship through re-entry with no communication blackout. We, of course, hello and good morning. You're looking at a live view of Starship, the world's most powerful launch vehicle and by far the biggest flying object ever made. We're currently at T plus 31 minutes and 24 seconds awaiting our third flight test of Starship from Starbase, Texas, or what we here at SpaceX like to call the Gateway to Mars. Thanks for tuning in. We're excited to be joining you from SpaceX headquarters in Hawthorne, California. Now it's just been 100... You can tell the crowd is already excited behind us. Now, it's only been 117 days since our last Starship test. And for those of you following along, you'll know there's nothing more exciting, as you can hear, than to watch a developmental flight test.
That's absolutely right. Flight test days guarantee the maximum level of excitement, as you can hear behind us. And if it all goes well, Starship will lift off just about 30 minutes from now. We're hoping to surpass what we achieved in flight test number 2 back in November of last year. But regardless of today's outcome, the goal is to collect as much data as possible, and that'll help us get one step closer to a fully operational Starship. Now, Starship, which you see on your screen, is the latest and largest vehicle developed to date by SpaceX and in the world ever. Compared to Saturn V, the rocket that first took astronauts to the moon, Starship has more than twice the thrust, and with some upgrades that are planned for the future, it'll have 3 times the thrust.
Starship will allow us to fly the heaviest payloads ever flown, land humans on the moon again after more than a half century, and ultimately fly humans further into space than ever before, even to Mars. But the most important thing about Starship is that it's designed to be a fully, rapidly reusable, reliable rocket, or what we like to call the 4 Rs. And we'll talk more about those later in the webcast. But before we dive into the details of today's test, let's recap the achievements of our last integrated flight test, Flight 2. All 33 Raptor engines on the Super Heavy booster started up successfully and, for the first time, completed a full duration burn during ascent. As you can see here, we saw amazing views of each Raptor engine burning during that ascent, which is something awesome because we don't get to see that with Falcon and its Merlin engines.
Now, next, Starship executed a successful hot stage separation, powering down all but 3 of Super Heavy's Raptor engines and successfully igniting the 6 second stage Raptor engines before the vehicle separated. This is the first time this technique has been done successfully with a vehicle of this size and scale.
Following separation, the Super Heavy booster successfully performed its flip maneuver and initiated the boost back burn. However, about 30 seconds into that burn, it experienced a rapid unscheduled disassembly, or RUD. That's SpaceX speak for an exciting end to the booster's journey. The likely cause was determined to be filter blockage, where liquid oxygen is supplied to the engines. So we've upgraded hardware inside the oxygen tank to improve filtration capabilities in our boosters, including the one that's out on the pad today. Vehicle breakup occurred more than 3.5 minutes into the flight, about 90 kilometers over the Gulf of Mexico, so well away from people.
Now, on Starship, the 6 second stage Raptor engines all started successfully at separation, and everything was going normally in the ship's climb to space until about 7 minutes into the flight, when we began a planned vent of excess liquid oxygen propellant. To simulate the mass of a payload and get future-focused data, the ship was loaded with extra propellant that we needed to get rid of or vent before re-entry. Once we started venting, though, a leak developed that caused fires, which eventually cut the connection between the flight computers on the ship, and that caused the 6 Raptor engines to shut down before we had finished the full burn. That was detected as a mission rule violation by the autonomous flight safety system, which triggered the flight termination system and led to vehicle breakup.
Starship's second flight test nearly completed its full duration burn. It ended at an altitude of about 150 kilometers and a velocity of 24,000 kilometers per hour, officially making it the first Starship to reach outer space. Like the booster, we've made upgrades to Starship's upper stage based on Flight 2 learning, such as improved leak reduction, fire protection, and changing the operations to increase reliability.
Now, back at the launch site, the new water-cooled flame deflector and other pad upgrades performed as expected, so the pad required minimal post-launch rework. And that's a big reason why we are ready to fly again today. The ground support systems are designed for rapid turnaround of the launch pad between flights, and the improvements we've made ahead of Flight 3 are getting us closer to that goal. And that brings us to today's test. The test profile and the burn timeline are very similar to test number 2, with one major difference. The ship will attempt to splash down in the Indian Ocean rather than the Pacific. This puts us on a steeper trajectory than past flights and lets us test capabilities that we'll need for the future, like lighting a Raptor in space while maximizing public safety. So let's take a closer look at the flight test profile. Now, about 26 minutes from now, Super Heavy will ignite its 33 Raptor engines and lift off from Starbase. About 3 minutes into the flight, Super Heavy's booster will separate from the ship in SpaceX's second ever attempt at a hot stage separation. That means it'll light its engines while still attached to a partially lit booster. The ship's engines will then remain lit for about 6 minutes during the ascent before entering a coast phase.
Next, the booster will perform a flip maneuver and execute a boost back burn, which, if you recall, is where Flight 2 Super Heavy experienced a rapid unscheduled disassembly. We're hoping hardware upgrades made for this flight will get the booster closer to executing a landing burn in the Gulf of Mexico. In the meantime, Starship will coast for about 30 minutes at altitudes between 150 and 235 kilometers, and the ship will attempt to fire a single Raptor engine for our first ever relight of a Raptor engine in space. And from there, the ship will head toward its destination, splashdown location in the Indian Ocean. Again, if we get past a successful stage separation and a full ascent burn with the upper stage, it will be at an altitude and trajectory below orbital, meaning Starship won't have to fire its Raptor engines for a deorbit burn, and it will naturally come back into the atmosphere no matter what.
Now, meanwhile, the Super Heavy is going to attempt a landing burn before splashing down into the Gulf. And while we are going to practice a landing, we aren't planning to recover any of the hardware from Super Heavy or the ship on this flight. Now, with the exception of Falcon, this is no different from what happens with most rockets flying today that are expended or fall into the ocean after they complete their mission. Eventually, though, we will land and recover Starship boosters and ships, just as we do with Falcon 9 and Heavy boosters, where we've recovered 283 to date. Starship's rapid reusability is key as we begin missions to the moon and beyond.
Even though recovery is not planned, the telemetry and data we receive all the way to the end is what we're looking for, particularly with regard to the ship's temperatures during reentry and how the heat shield will perform. The data that we gather today, of course, will help us continue to build a rapidly reusable Starship for the future. Now, much like our first 2 flight tests, today also still just a test. Our goal is to gather data to continue iterating and ultimately improve Starship.
That's exactly right. The primary goal for Flight 1 was to clear the pad, and we did that and got a lot of great data that helped us improve the vehicle and the pad infrastructure that you see today. The primary goal of Flight 2 was to get all the way to stage separation, which we did, and even got a little extra.
For Flight 3, we've added some ambitious tests highlighted by an attempt to transfer several tons of propellant between the tanks inside Starship itself, as well as the first ever relight of a Raptor engine in space and the opening and closing of Starship's payload door. When Starship takes astronauts to the lunar surface as part of NASA's Artemis program, it will be refilled in space by a Starship tanker spacecraft before boosting itself into a lunar orbit, like you see here. Transferring a large amount of cryogenic liquid in space has never been done by anyone, ever. So we'll be looking to get data on some of the fundamental physics in play here, like managing pressures, temperatures, propellant settling, all as we prepare for eventual ship-to-ship transfers. The ability to refill Starships once in orbit will be critical for landing on the moon and is a key technology for enabling deep space exploration and ultimately flights to Mars.
Now, we're also attempting the first ever relight of a Raptor engine in space, and we'll need that capability for future in-space maneuvers and deorbit burns. It's important to note that what we'll attempt today is not a burn required for Starship to re-enter on today's test. We are intentionally flying this new steeper trajectory so we can test things like engine relights without substantially changing where we expect to splash down. And if Starship manages to make it all the way to re-entry, we will collect valuable data on the vehicle as it flies through the Earth's atmosphere at hypersonic speeds, or more than 5 times the speed of sound. We expect it'll look something like this animation on your screen with the heat shield tiles facing down. We'll use the Earth's atmosphere to brake the vehicle and then get us into a controllable regime as we go towards splashdown. Now, we did validate Starship's ability to fly and land at subsonic speeds during our suborbital flights several years ago. And gathering data on the aspects like heating and vehicle control while we're traveling way faster will become critical to eventually bringing Starships back from space for rapid reuse.
We'll also attempt to open and close Starship's payload door for the very first time, a capability that we'll need when Starship starts flying our next generation Starlink satellites. And there you can see an animation of what that will look like as the satellites are deployed one by one through a slot near the top of the spacecraft. So at this point in time, we are approaching T-minus 21 minutes until liftoff. Let's check in with Dan for a countdown update.
Hey, thanks, Kate. Hey, everybody. I'm Dan Hewitt. Good morning. Welcome to Starbase. I'm coming to you from the Raptor's Nest, where I'm here with some of our flight controllers, also our Pad Red team. We're just behind the Mega Bay. Those are Super Heavy boosters right behind me, getting ready for the next 4 flights after this one. So we're looking to launch a lot this year. Countdown has been pretty clean so far. We're not tracking any issues that are gating us on the hardware side and the vehicle side from that on-time liftoff at 8:25 a.m. Central Time. That's our T0 right now. We primarily shifted later as we were just working to clear the range. The other big watch item today is going to be the winds. The winds have started to pick up. We're still looking to be below our limits, but there could be a hold at T-minus 40 seconds just to make sure that the winds are acceptable before we go. We are actively loading propellant on board the vehicle. You can see by the frost lines starting to build up. Looks like we're about 80% on the ship main tanks right now and a little over 60% on the booster. Now, Starship uses liquid methane as its fuel, liquid oxygen as its oxidizer. Both of those get cooled down to cryogenic temperatures, so several hundred degrees below zero. And if you followed along with our previous 2 flight tests, the prop load timeline today looks a little bit different. Those first flight tests, it took us about 90 minutes to load all of the prop on board. But since the second flight, we made some pretty significant upgrades to make that time shorter. We added some additional fuel and LOX pumps just to increase our capacity. We expanded the number of heat exchangers and installed a dedicated fill drain line for each stage. But they were sharing one before, now they each have their own. That's just that main pathway to get the propellant to the vehicle. We're aiming for about 51 minutes for today's operation to fully load prop. We did that successfully on our wet dress rehearsal that we did recently. Eventually, though, we're trying to get that time down to about 40 minutes. Just for some context, that's about 5 minutes longer than we take on Falcon 9, but we're doing it with 10 times the amount of propellant. Now, the propellant load on ship started at about T-minus 53 minutes, booster right around T-minus 42 minutes. We are about to pause loading on the main tanks of ship, switch over to the header tanks, and then switch back to close out the main tanks. We're expecting all of the prop to be on ship at about T-minus 3 minutes 30 seconds, and then booster prop load ends at T-minus 2 minutes and 50 seconds. Now, our final countdown and startup sequence is going to be the same as Flight 2. We already tested this on this booster when we did its static fire. Looking back for Flight 1, we lit those Raptor engines on the booster and lifted off about 6 seconds later. Flight 2, we reduced that time by almost 2 seconds. That just helps reduce the stress on the ground systems, improve the efficiency of the rocket. But right now, we're just about to pass 18 minutes away from launch. Winds, again, they're still looking a little bit marginal, so we'll keep an eye on those. We're not working any other technical issues, and the range is expected to be green. If we can't make our test today, we have backup launch opportunities in the coming days. Could be 24 to 48 hours, all just depends on how far we get into the count. So check back in with everybody in just a little bit. For now, though, I'm going to send it back to Kate and Shiva out at Hawthorne.
Thanks, Dan. The countdown is continuing to progress, so let's take a closer look at the world's most powerful launch vehicle ever developed. Starship is comprised of 2 elements, the ship, which has 6 Raptor engines, and the Super Heavy booster, which has 33 Raptor engines. Starship is capable of about twice the thrust of the Saturn V rocket, and with future engine upgrades, it will actually be 3 times more powerful.
Now, with those future improvements, that'll allow Starship to carry somewhere between 150 and 250 metric tons to orbit, depending on the configuration. For reference, Falcon 9's heaviest payload to date is just over 17 metric tons. So with Starship, we're talking about an order of magnitude greater in terms of payload capability to orbit. And that matters because the amount of mass we're able to launch per rocket is critical to creating a self-sustaining city on Mars.
In terms of size, the Super Heavy booster alone stands about 71 meters or 233 feet tall and is about the same height as a fully integrated Falcon 9. The ship stands about 50 meters or 160 feet tall. Stacked together, the booster and the ship are by far taller than the Statue of Liberty, which stands at 305 feet tall with its base. Stacked together, Starship is 396 feet, so quite a bit taller there.
Now, Starship's first stage has a diameter that's about 2.5 times that of Falcon 9, and when we've got those 33 much larger Raptor engines, this great view of the launch mount looking up at those engines, and we need them to power through the Earth's atmosphere and gravity to deliver those massive cargo and payloads up to space. Moving up the rocket, Starship is designed for vertical takeoff and landing on any hard surface, and that's as opposed to taking off and landing on a runway as aircraft do. And that's important because there are no runways on the Moon and Mars where we're going. The ship, which we're looking at now, features 6 Raptor engines. 3 of them are sea-level engines, 3 of them are vacuum engines. That means that those vacuum engines are optimized with a larger engine nozzle to operate in the vacuum of space and get us higher performance.
The ship is also outfitted with 4 flaps to help aerodynamically control the vehicle's attitude during atmospheric flight and enable a precision landing. The body of Starship is also wrapped in a heat shield made up of 18,000 hexagonal ceramic tiles. Those are designed to insulate the vehicle during atmospheric entry, where temperatures can be as high as 2,600 degrees Fahrenheit. One of our test objectives today is to verify how Starship systems and thermal protection system tiles perform during reentry. And in between the first and second stages is our hot stage, which is critical for our newest separation technique, which we saw in action during flight test 2.
Yeah, that was a pretty exciting first for our team. Hot staging had never been done before as part of a reusable space transportation system, let alone on a vehicle with the size and power of Starship. Now, at about liftoff plus 2.5 minutes, the booster shut down most of its 33 engines, leaving just 3 of them running, and then the ship simultaneously ignited all 6 of its engines. Some clamps separated, and the ship thrusted away. That was the first in-flight test of the heat shield, and we were able to gather a ton of valuable data about hot staging.
We maximized the vehicle's performance by leaving 3 first-stage engines on, so gravity can't rob us of precious velocity, or at least not as much. Hot staging also helps to ensure the ship's liquid propellants are at the bottom of the propellant tanks, which is where we need them to be in order to quickly light the ship's engines. It also reduces risk at stage separation because it creates a passive staging system so that physics will be doing the work instead of mechanical parts pushing the 2 stages away from each other. Ultimately, hot staging could increase Starship's payload to orbit capacity by 10%, which directly translates to more payload and more people to the Moon and Mars.
Now, the first stop will be the Moon, and the SpaceX team has been hard at work proving out all of the systems necessary to make that possible. Critical systems for propulsion, life support, and even the elevator that you see here, which will take crew and cargo from the Starship hatches down to the lunar surface, are currently in development. And the data that we gather from each test flight helps inform their design. Here we've got a photo of some of the mock-up suits that are used to demonstrate the range of mobility that astronauts will be expected to have. And we were using these to do human factors demonstrations and figure out the layout of the elevator. So all awesome development work for a future moon mission.
Super cool. Now, SpaceX will perform one uncrewed demonstration flight before NASA's Artemis 3 mission, which will be the first human surface expedition since 1972. After those first expeditions, we'll be ready to fly more people along with everything it takes to build a moon base. There's so much to look forward to. It's incredible that humans are finally going back to the moon.
You couldn't have said it better, Kate. And the moon is just the proving ground. It's just the start. When the time comes to make the leap to Mars, everything ramps up by orders of magnitude. The logistics of supporting an entire city on Mars are daunting and will require millions of pounds of cargo flown from Earth and spread out over thousands of launches.
And today's flight test is one more step toward that ultimate goal. We're currently at T minus 11 minutes, 47 seconds. Let's check in with Dan once again for a countdown update.
Hey, Kate, still good news from down here at Starbase. We're not tracking any technical issues that are going to block us to a launch. Our T0 time still holding to 8:25 a.m. Central, so just about 11 and a half minutes from now. The real thing we're going to keep an eye on is the winds once we get there. We do have that potential hold at T-minus 40 seconds where we can hang out and either let winds die down, make sure we're in the right structural limits, everything like that. So don't be surprised if we do a hold at T-minus 40. We've done those on previous flights, but we are not tracking any technical issues. The range is going to be green for launch, so all of that really great news. We're still loading propellant on the vehicle, on the ship. We're just about done loading the header tanks, the 2 smaller tanks in the top, and then we'll go back to the main tanks. Are about 85% full, and then booster, both fuel and LOX over 80%. So looking good there. The launch pad itself is getting ready for liftoff. We commanded the booster hold downs open already about 20 minutes ago or so. And then that just means that once that rocket has sufficient thrust to overcome its weight, your thrust to weight ratio goes over 1, it's going to lift off. We don't have a command to actually release the hold downs once it starts up. Just also a reminder, actual liftoff happens a few seconds after you see those engines ignite. So you'll see fire, and then a few seconds before Starship really starts to take to the skies. Our range team just going to keep on making sure land, sea, air are all clear, as we really count down. But that's the latest. We're just coming up on 10 minutes before launch. Everything looking good for Starship's third test flight. I'll toss it back to you guys in Hawthorne.
Great, thanks, Dan. Now, if you've been following SpaceX over the years, you've no doubt heard us talk about our goal of full and rapid reusability. Nearly all of the Falcon boosters flown last year and this year have been reused, or as we like to say, flight proven.
We've landed Falcon 9 and Falcon Heavy boosters 283 times since first doing so in 2015. And with Starship, our mission is to take reusability even further by reflying both stages with little downtime between flights. And we plan to fly as often as possible. As we mentioned earlier, rapid and complete reusability is critical to enabling routine spaceflight. The team at Starbase has been hard at work developing and manufacturing the hardware that will ultimately take humans back and forth to the moon and Mars.
Now, even though we are not recovering Starship today, test flights like these provide the critical data that we need through every phase of flight. And that data informs future missions and gets us to that future where Starships are being recovered and rapidly reflown.
Our teams are also working on the ground systems that will support rapid reusability. When we start recovering Starship boosters, we'll want them to return to the launch site for a quicker turnaround, as you can see here depicted in this animation on your screen. This is when the tower reveals its dual purpose. After launch, the arms or the chopsticks on the tower will help guide the booster into position to ensure a soft landing. Now, if you're thinking that this sounds hard or even impossible to do, well, that's the inspiration for naming them chopsticks. Some of you might recall a little film called The Karate Kid, where Mr. Miyagi famously taught the main character, Daniel, that if he could catch a fly with chopsticks, he could accomplish anything.
Now, today we do have 4 ships and 4 Super Heavy boosters built, with more coming off the production line as our Star Factory continues to grow. These vehicles are slated for future flight tests just like today's, and in fact, just this week we static fired our next ship that's planning to fly and expect to test the booster as soon as the launch mount is free from today's flight test.
Now, as a reminder, today is still just a test. While we really hope to get our splashdown location in the Indian Ocean, but any data received will help us improve. It's the third of many future flight tests for Starship before it becomes fully operational.
And that's the goal of flight tests. They teach us about the limits of our design and improve our understanding of the vehicle, and ultimately help us make Starship more reliable and rapidly reusable. So whatever the outcome and however far we get, we can promise excitement. And things look like they are moving fast at Starbase, and that's exactly how we like it.
Yeah,
Rapid
exactly.
Iteration is a key of SpaceX.
Yeah, we've done it with all of our major innovative advancements, including Falcon, Dragon, and Starlink. We believe that if you're not failing, you're not learning and improving the design.
Yeah, many of the innovations that we've developed have come from our failures, and they teach us how to avoid the perils of spaceflight. It's a tough business. But all of this testing, all of the iterative design allows us to make the design better and better to do some of the great accomplishments with reflight that we've had so far.
Exactly. One of the examples that we love to talk about is the Dragon capsule, like the one located behind Shiva and I here on the mezzanine. Originally, it was not designed to be reusable. We wanted to prove the initial design. And then when we brought Dragon 2 online, we had to do a lot of corrosion analysis based on flights that had splashed down and analysis on hardware received there. And now our Dragons are reusable and also rapidly, at a much rapid pace than they used to be.
Yeah. So, I mean, great learnings from our original Dragon to our new crew and cargo vehicles have directly improved the operations, and they've helped us change our understanding of what's possible when it comes to rocket and spacecraft reusability. Now, we're just under T-minus 6 minutes, so I think it's another good time to check in with Dan for the rest of terminal count. How are we looking, Dan?
Thanks, Shiva. We're looking good. 5 minutes, 35 seconds, and we're counting down. We are just about at closing the prop load sequences on booster and ship. Just a reminder, ship we're going to close out at around 3 minutes and 30 seconds, booster at about 2 minutes and 50 seconds. Once all of that prop is loaded on board, we'll have about 10 million pounds of propellant on both stages of Starship. Now, after that happens, we'll go through a couple of different procedures with the ground. We'll do what's called pushbacks, clearing out the lines between our prop farm and the vehicles themselves before we get to launch. And then in the next few minutes, we'll get the final guidance system alignments, some final thrust vector control on the booster checks, and all that will be performed. And again, if we need to hold, we have a hold gate built in at T-minus 40 seconds where we can hang out. It sounds like today we'll have about 15 minutes to hold at T-minus 40 if we need to. If we hit that right now, it looks like the most likely reason would be winds. We're not tracking any technical issues to our T0 at 8:25, just about 4.5 minutes from now. So, I mean, everything's really looking good. The booster's almost at full frosty, so we'll see that close out in just a couple of minutes. But we're getting really close to flight, guys.
The excitement is definitely growing here in Hawthorne, SpaceX headquarters. There is a large crowd gathering. You might hear them cheering occasionally. Now, Dan mentioned a good point about the holds. We have an opportunity to today hold for a few minutes. And this is a really cool thing about Starship. And we don't have this opportunity with Falcon or Falcon Heavy. Up until the T-minus 40 second point, aborts are just holds. So anything that would trigger an abort prior to T-minus 40 seconds becomes a hold. So that's a really cool feature to allow the team to wait for final checkouts or assess prop levels, engines, avionics, vehicle pressurization. It's really helpful to ensure a liftoff.
Yeah, and that's something that is very different from Falcon. I'm sure people have watched our launches, and then we get right down past prop load and then have to scrub because of weather or scrub because of an issue on the vehicle. And we don't have the same constraints on our propellant and our system with Starship, which gives us more availability in the window. And sometimes that's all you need. Sometimes the winds dip just enough where you can launch the rocket safely. And otherwise, if you didn't have that ability to hold a few minutes, you might miss that window and then have to recycle to another day.
Yeah, exactly, which is kind of like today. Like we mentioned earlier, winds are the thing that we are watching, so good news there. So we are still continuing to progress. We're looking at liftoff in just under almost 2.5 minutes from now. Super exciting. Like we said before, there's nothing more exciting than watching a test flight for a developmental program, and that's where we're at today.
And like we talked about, we have some really ambitious goals for today's test. But really, the point of today's test is to try to get as much data as we can so we can inform the next iteration of the design of Starship, work those things into flight test number 4 and new objectives there that'll eventually get us to that glorious, rapid, reusable future that we so badly want.
Yeah, for flight 1, we wanted to clear the pad, and we did. For flight 2, we wanted to get through hot staging separation, and we did. So today, we want to get even further than that and collect as much data as we possibly can. So with all that being said, we're going to check back in with Dan to take us through the final 2 minutes of terminal count.
All right, we are under 2 minutes away. We have closed out the prop load on the booster and on the ship. And we're starting to hear some good news that it looks like winds are not going to hold us up, so there's a good chance we blow right through that 40-second hold. So we're about 1 minute and 20 seconds away. Just walking you through one last time, we're going to see the engines ignite about 4 seconds before we hit our T0. They're going to ignite in 3 different banks. You'll get 13 of the inners, 15 of the outers, and then the last 5 ignite just 2 minutes before T0. And then after that, the quick disconnect will retract. The engines will start to throttle up, and then we'll see liftoff about 1.5 seconds after T0. So we're under 1 minute away. Don't be shocked if we hold at 40 seconds before, but it sounds like the winds are cooperating today. And we'll be able to move right past that, not tracking any other technical issues that could hold us.
Proceeding past our QD vent gate.
Through the QD vent gate, past that 40-second hold.
Go for launch.
Flight Director Ty Huntington telling the team we are go for launch. So 20 seconds to go. Let's listen in.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Booster after chamber pressure nominal.
30 seconds into flight, we are feeling the rumble. We are seeing 33 out of 33 Raptor engines ignited on the Super Heavy booster.
Booster and ship, avionics, power, and telemetry nominal. Acquisition of signal, Corpus Christi.
Continuing to get good call outs. Our trajectory looking nominal, systems looking nominal. Just amazing to see all 33 lit up once again. At this point, we've already passed through max Q, that maximum dynamic pressure, and passing supersonic, so we're now moving faster than the speed of sound, getting those onboard views from the ship cameras. Now the next major milestone is going to be a hot staging maneuver. Again, we're going to be doing that in just